Hey guys, this is problem 2.17 out of Griffith's quantum mechanics, and we are going to work through this problem together. Before I do it, if you wouldn't mind please liking and subscribing, I would greatly appreciate it. So this problem is pretty straightforward, but a lot of what we do is, this is used a lot in what we do, so it's kind of worth to go through it and make sure you understand the math behind it. So we'll start with showing the identity. We don't want text mode to pop up, so let's just go further down to be safe. A e to the I kx plus b e to the minus I kx. And for this we can use Euler's identity. So that would be A times cosine kx plus I sine kx. And then we can do the exact same thing with this other term, only we're going to take advantage of the evenness and the odd properties of sine and cosine, so that this can be just cosine kx. The negative won't change the even function, and we'll just pull that minus sign out here because sine is odd. And again, this is just Euler's identity. Very popular identity, we use it all the time. Okay, so that's all well and good. Now what we could do is distribute this A and this B, and in that case what we can do is factor out our cosine. So we'll have cosine of kx times, and I'll put it out front, A plus B plus I A minus B sine of kx. So all that we're doing here is grouping our cosines and sines together. And now we can rewrite this as sine times cosine of C times cosine of kx plus D sine kx. C is this term, and of course D is this term, which is what we have in the question that they're looking for. And if we want to go backwards, we can do that as well. So C cosine of kx plus D sine of kx. And the trick here is to write your cosine. So cosine of theta is equal to e to the I theta plus e to the minus I theta over 2. And meanwhile, sine of theta is very similar, except we have a minus sign here, and it's going to be, instead of dividing by 2, 2i. So that's our identity. So if we plug this stuff into here, you'll have C times e to the I kx plus e to the minus I kx divided by 2 plus D times e to the I kx minus e to the minus I kx all divided by 2i. Now we can group together our positive exponential terms. So if you imagine distributing the C and D, if we wanted to group together our positive and negative exponents, we could pretty easily do that. Okay. So let's start with the first one. We're going to have, let's just write it out. C e to the I kx over 2 plus d over 2I e to the I kx plus c e to the minus I kx over 2 minus d e to the minus kx over 2I. Okay, so now we can factor some of this out. We can factor out an e to the I kx, and we'll be left with c minus id. And we're going to factor out the half. So the I moved up to the numerator by changing the sign. And plus 1/2 c plus id e to the minus I kx. So we factored out the 1/2, and this I in the denominator moved up. So now it's positive. Well, A then is just 1/2 c, that's parentheses, minus id, and B is just 1/2 c plus id. So we proved it both ways. So hopefully that makes sense. It's not too difficult of a problem, but it does seem important to understand that. So if that helped, please like and subscribe. Thank you.